A metal sphere A of radius r has a charge q on it. The field at a point B outside the sphere is E. Now, another sphere of radius 2r having a charge minus 2q is placed at the point B. The total field at a point midway between A and B due to both the spheres is. So, this total field at the midpoint between A and B we have to find in terms of the initial electric field that has been created by a single sphere A. Say the distance between A and B is some d, and while calculating the electric field, so we measure the distance from the center of the sphere. Okay, so let us calculate this. Say there is a sphere here, sphere A, it has radius r, and it has charge q, and this is the point B. Say the distance of the point B is d. So if it has positive charge, electric field at this point B, sorry, say it's a point B. So this is A and this is B, the point is B. The distance of the point B is D from A, and the electric field at this point B will be away from this positive charge. So we are going to find the magnitude of this electric field. So E equal to kq divided by d square, because even though it is a metal sphere, this point B is outside the sphere. For any outside point, so the spherical charge behaves like a point charge placed at the center. So the distance of the point B is measured from the center of the sphere. So a spherical charge behaves like a point charge placed at the center for any point outside the sphere. So say this is the equation number 1. Now, the second case, this is sphere A, it has charge Q. In the second case, so they have placed another sphere of radius 2r and charge minus 2q at the point B. This is point B. Now, at the midpoint, we have to find the net electric field. So at the midpoint, so this sphere A will produce electric field away from it. Say it is E1, and this minus 2q, this B will produce electric field towards it because it is negative charge. So E1 and E2 at the midpoint will be along the same direction. So this will be d by 2, this distance will be d by 2. Now we have to calculate what is E1 magnitude. E1 is the electric field produced by the sphere A. It is k q by d by 2 whole square, so which is equal to 4kq divided by d square. Similarly, E2 will be, the E2 is the electric field produced by the second sphere. Don't substitute the negative sign of the charge. That negative sign will be taken care of by the direction. So k 2q divided by d by 2 whole square. So which will be equal to, it is 8kq by d square. So E1 and E2 are in the same direction. So what is the net electric field at that point P? It is E1 plus E2. So it is 4kq divided by d square plus 8kq divided by d square. So which is equal to 12kq divided by d square. If we see the equation number 1, in place of kq by d square, we can write E. So 12E. So what is the net electric field at the point P? It is 12E. It is 12E. So option C is correct.